Exceptions. Exceptions are problems that happen during the runtime of your program. One of the most important features of a debugger is to allow you to spot and understand exceptions in your program. Some examples for exceptions would be trying to divide by 0 with the div instruction, or maybe writing to a memory location which you do not own, and so on. I'm not going to expand much about exceptions, but I do want to make sure that you know how to recognize an exception when you see one. Let's see then a few examples. The first one is called division by 0. Before even taking a look inside the code, I want to assemble and run this program, just to show you the effect. We first assemble this program, and next we run it. As we can see, we have this small pop-up which says that division by 0.exe has stopped working. A problem caused the program to stop working correctly. Windows will close the program and notify you if a solution is available, which means that something went wrong with the program, but the operation system doesn't really tell us what went wrong. It could be pretty hard to program this way, when you do not really know what went wrong. In some cases, it might be that you don't even have the source code. Maybe you only have the executable file, and you try to understand what is the problem. In those cases, having this kind of pop-up is not very helpful. Let's see how we can use WinDBG to find out what is the problem inside this program, even before we take a look at the source code. We open WinDBG, and next we open the file. I copy the path, paste it here, and I pick division by 0. Division by 0.exe is opened in a pause state, and the debugger is waiting for commands. At this point, we don't really need to put a breakpoint on the entry point. We can just use the G command. Let's use it. We can see that something happened. This is the output of the G command. It says integer divide by 0, and there is also a code for the error. Basically, this is how an exception looks like inside WinDBG. As usual, we get the full state of the program, all the registers, and also the current instruction, the instruction which caused the problem, which is just div EAX. WinDBG's assembly syntax is a bit different. This is why you see that this instruction has two arguments. In fact, in FASM, it would be written just as div EAX. At this point, let's take a look at the source code of the program, just to make sure that we understand where this instruction corresponds to. This is the code of our program. We can see that it only has two instructions, XOR EAX EAX followed by div EAX, which means that this program basically is all about division by 0. We just divide by 0 some number. This is why we get this exception, integer divide by 0. This is really a simple program, maybe even naive. Usually your exceptions will come from unexpected things. After you use the debugger and find an exception in your program, you could then go to the source code and try to solve the problem. This will not always be very easy, but sometimes it is. Sometimes you will have to search more, maybe using some other features of the debugger to find out how did the problem occur. We stop debugging using Shift F5 and we move on to the next example called access violation. This time we do begin by taking a look at the code. This is also a very short program. It first zeroes EAX and then it tries to write into location 0 in memory the D word 3. When working in protected mode, which is what we do in this course, whenever you try to write or read from location 0, you are going to get an exception. Location 0 in memory is a special place. Nobody can write or read from this location in protected mode. Therefore, this program is a good demonstration of an exception called access violation, which is what happens if you try to write or read data to a memory location that does not belong to you. Let's assemble and run this program. As expected, we have this pop-up which says that some problem has occurred. We know that the problem is that we tried to write the number 3 into location 0 in memory. Let's see quickly how it looks like inside WinDBG. We pick accessviolation.exe. Next, we just use the G command and we get this description of the problem. Access violation, there is also a code number, and we get the instruction where the problem has occurred. I want to tell you about another command that could be used to get further information about the exception. It is called analyze v. Usually if you have the code of the program and if you are an assembly programmer, you will not use this command because you already have lots of information about the problem, mostly if the program is yours. However, sometimes you might want additional information. Let's see the output of this command. As we can see, we got a lot of output. I don't want to expand right now about understanding everything here, but I just wanted you to know about this command. We stop the debugging using Shift F5 and we move on to the next example called int3. Let's take a look at the source code. This is another very simple program. It contains this instruction, int3, which is going to be encoded as CC. I remind you that int3 is the instruction used for software breakpoints. It is interesting to find out what happens if we put such an instruction inside our code. Just as a side note, if you ever try to use this instruction in FASM, make sure to use this syntax and not, for example, int3 with a space in the middle, which will encode as another instruction. We save this file, and next we assemble the program and run it. As usual, we get this pop-up which says that a problem has occurred. Not very informative. Instead, let's try opening with WinDBG. We use the G command, and we see that we get to an int3 instruction. If we open the disassembly view to view more instructions, we can see that this is really our code. Let's compare it for a moment. This is exactly our code. We have int3 followed by push 0 and then a call to exit process, which is exactly what we have here. In this case, we can really continue to the next instruction. Step into. This might be a bit of a strange demonstration because this is not a usual thing to do. People do not usually put int3 inside their program. But I just wanted to show you how it looks like. Note the information that you get from WinDBG. Break instruction exception. Using this instruction, int3, really yields an exception, which is called break instruction exception, and it has a specific code. Let's summarize this lesson. In this lesson, we've seen how to inspect exceptions. We've also seen that we don't get much information about exceptions from the operation system whenever we run a program that crashes. We just get this strange pop-up that says that something went wrong. In those cases, it would be a smart move to use the debugger to get more information about the exception. For example, to see what went wrong, at which instruction, and also maybe a short description of what happened. If we ever want a longer description of the problem, we can always use the analyze v command. In this lesson, we have seen 3 specific types of exceptions: division by 0, access violation, and int3, which is break instruction exception. Of course, there are more. You will probably meet those at some point in the future.